Very good morning to everyone. I hope I am audible to everyone. If I'm audible, then please simply raise your hands to confirm this. Okay, okay, that's great. First of all, thank you so much for joining the session in a very short notice because we were informed through the forum that there is some maintenance work that will be going on Sunday. So that's why we have to prepone the session for today, right? So, okay. So, can you please confirm whether you have practiced the project that we have discussed in the last project discussion session? There are only two responses. What about others? Okay, yes, I practiced that. Yes, sir, little bit. What is the meaning of little bit here? Because I have discussed a single project, and then after that, you have a whole 1 week, right? Okay, so have you learned about the new concepts, how to use them, how to use different modules together to work on any kind of project? Yeah, very good. Yeah, very good morning. Yeah, okay, great. Okay, so can you tell me what was the name of the project and which type of project we have discussed in the last session? Okay, okay, great, great, great. Okay, so what is the most important thing in any kind of machine learning project? What is the most important thing? I'm saying, what is the most important thing in machine learning projects? I'm asking what is the most important thing. I'm not asking about the important things in machine learning project. Okay, because Neha Ojha and Bubbly Singh, whatever you are saying is incorrect. Right? I'm asking about most important thing. I'm not asking about the important things that we can use in any machine learning project. Okay. Okay, so most of you are saying correct because your answers are correct. You are mentioning about the most important thing. Okay, so the most important thing is problem statement because by reading the problem statement, you understand what the customer or what the problem wants from you. Okay, it means what you need to do, what is the exact problem, what you need to solve, right? And based on the problem statement, based on the requirement, you can say if any customer is giving any kind of project, then it means what is the customer requirement, right? So by reading the problem statement, you will be able to understand about the customer requirement, and based on that we are scraping the data, or we are collecting the data. If the data is provided by the customer itself, then in that case we are doing the analysis, we are checking the algorithm, right? We are doing the analysis, we are doing the feature engineering, we are doing the pre-processing, right? So we are doing everything based on the problem statement, means what we need to achieve, what we need to solve, right? So the most important thing is problem statement and understanding of the problem statement. Clear? Okay. Okay, so please wait and let me share my screen. Okay, can you please confirm whether my screen is visible to everyone? So today we are going to discuss a new project, because last project was basically based on the classification, right? We have discussed about the classification task, but today we are going to discuss a new project that is basically related to another problem statement, right? So here, first of all, we are going to read the problem statement, and here, as per the problem statement, here it is mentioned that the data set contains the Tesla stock from 29th of June 2010 to 3rd of February 2022. Okay, it means this is the stock for a of a company, right? Now it is mentioning about the Tesla stock. Can you please let me know what is Tesla? Please tell me what is Tesla. Any one of you? Okay, someone saying electric car company. So most of you, I am saying all of you are saying that is electric car company, right? Okay. So if I'm saying Tesla is not just an electric car company, then because the person who is the CEO of Tesla company, please don't say Mark Zuckerberg. Okay, he is a CEO of Facebook and Meta. Okay, yeah, Elon Musk. Okay, Elon Musk is basically is the CEO of this company, right? But the Tesla is taken from somewhere else, right? The name of the Tesla company is taken from somewhere else, because the Tesla is not only limited to the company. Okay, Tesla is basically it is a unit. Those who are from science background, basically those who have learned about the physics, they are well aware about the what is Tesla. Tesla is basically a unit, that is basically a unit of magnetic field intensity. Okay, I hope you have heard about it, right? If you have not heard, then no worry. I'm just giving this information so that you can know about what is Tesla, instead of only the car company. Okay, so Tesla is basically it is the unit of magnetic flux density. Clear? Or you can say magnetic field intensity. Clear? Okay. So here, but here we are talking about the Tesla company, right? Those who are saying it is a car company, that's correct. So basically here we are talking about the stock of Tesla company, right? And here it is mentioned that the Tesla has been on the rise recently, means there was a sharp increase in the price of Tesla company with a crazy of 100% 100+% spike in the last 30 days alone, right? So it means the stock prices was increasing very rapidly, right? Then after that, with the history, maybe we can find out why. Clear? Now, this Tesla stock includes open, value, low, high, low, close, adjacent close, and volume, right? Okay. First of all, please let me know please let me know whether you are investing in the stock market or not. Please let me know. Because if you are investing, then it will be more easy to understand about the stocks. Saying yes, some of you are saying no. Okay, so those who are saying yes, can you please let me know what is the open value, what is the low value, what is the intraday trading? I hope you have heard about these terms, those who are investing. I have received a single answer from the person who is investing in stocks. What about others? Okay, so Kirti is saying intraday is intraday the same day sell and buy. That's correct. Basically, we are purchasing the stock when the share market opens, and before the end of the day, we are selling our stock, right? And basically we are continuously monitoring the price, okay, price of the stock, how my stock is performing, and based on that we are making the decisions, right? So this is all about the intraday, right? Now there are different values, right? The first one is open, high, low, close. So open is basically when your when the price of the stocks when the stock market or share market open, right? So at that time there are different values, right? So here they have mentioned about the five terms, sorry, seven terms: open, high, low, close, then adjacent close, and the volume, right? Now in stock trading, the high and the low refer to the maximum and the minimum prices in a period of the time. For example, if we are checking about for the 6 hours, for one day, for last 7 days, for 1 month, right? So there is one minimum price and there is one high price. That is basically low price and the high price, right? Open and close are the prices at which the stock begin. Means when the stock market opens, at that time there is a price of every stock, right? And then after that, the close is basically referring the ended trading in the same period. Basically, if we are checking for a same period of the time, for example for one day, then we will check what was the starting price of the stock, and then after that at the end of the day what is the closing price of the stock, right? Then after that, volume is the total amount of trading activity, means how many stocks are basically traded. Some customers have basically sold their stocks, some purchased, right? So there are means overall the transaction of the stocks. Clear? Then after that, adjusted values factor in corporate action such as dividend, stock splits, and new share issuance. Like there was one stock in the market named as IRCTC. Then after that, they split it into four parts, right? So if you're dividing, right, or if you are merging, so based on that we are calculating the adjacent closing price, because while calculating the adjacent closing price, we are uh, uh, considering so many factors, right? After considering so many factors, we are deciding what is the adjacent close price of the stock. Clear? Okay. Okay, oh, close value is when the market close. That's correct. Now, what we are doing, basically, we are first reading the data, but before that, we are here again, we are checking the what is the variable. So here, basically, we have 1, 2, 3, 4, 5, 6, 7, total 7 columns are there, right? And what is the dimension of the data? The dimension of the data is 2416 rows and 7 columns. Okay, so it means the number of rows in this data set are 2416 and number of columns are 7, right? Then after that, we are reading about what is the variable. So here basically the date is basically representing the date of the transaction. Okay, for example, if today is Saturday, right? If the stock market is closed, then the transaction, there will be no transaction today, right? If the stock market is opening on the Monday, then definitely there will be some transactions. So the transaction Monday will be considered as the transaction day. Clear? Then after it open, it basically represents the initial share price of the relevant trading day, means when the stock market opens, right? Then after the high basically represents the highest price, low is lowest price of the relevant, close is basically closing price of the stock market, adjacent close I have already mentioned, volume is basically representing the trading volume information, right? Now if you check here, so basically here you can see on the 29th of June 2010, the open price of the stock was $19. Okay, because the Tesla is a USA based company, so their currency is dollars, right? Okay, so basically US dollar, right? So here the opening price of the stock market was $19, means the price of single share was $19. If you are purchasing 10, then you $10 10 share, then you have to purchase $190, right? The high price for the same day, basically whenever we are investing, so basically they are changing the low price, high price, right? Some limits, right? They are setting based on the transaction history. For example, if the initial price of the stock market was 19, so they will set a market, for example 24. They are selecting that, okay, they are giving information. If you are investing, it doesn't matter what platform you are using, Grow app, Angel One India, okay, Angel One or other stocks. So basically if you are investing, then you will see they are giving different information, means what could be the maximum value of the price for a day, right? So for example, if they are setting $24, right, but the stock market price was increased and it crossed the $24, then they will change the maximum price. Okay. Or they have they said that, okay, the lowest price will be $17, right? But due to some reason the stock price decreased and it like reaches to $15, then again they will change it. So basically they are changing continuously, means they are changing the open, they are changing the maximum price and the lowest price, and based on that they can, or they are also predicting what could be the closing price, right? So based on that, based on the performance of the stock, every second we are making decisions whether we should keep it, whether we should sell it, whether we should purchase it, right? So based on the performance of the stock within a single day, we are making the decisions. And these decisions, means the lowest price, the highest price, that is basically changing continuously, is most important if you are investing, if you are doing a intraday trading. Because in the intraday trading, we try to get the maximum profit, right? And we try to avoid the maximum loss, right? So what we are doing, we are basically continuously tracking down the performance of the stock, okay, over a period of the time. For example, if you are checking for 1 hour, 2 hour, 3 hour, right? So basically you have to invest more time now in the trading, okay? And based on that, we are selling or purchasing it. So basically here you can see the stock price. What was the maximum stock price on 29th of June? That was $25. The lowest price was $17.54, and the closing price was $23. So basically if you have purchased a single stock of Tesla on 29th of June, so at the end of the day you are in profit, right? And the profit was basically $4.89 per stock. So if you have purchased 10 stocks, then definitely your total profit is around $41 or $42, right? So in the same way, here now the adjacent closing price was basically again 23.899, right? Then after that, what is the volume? The volume is basically 18766,300, means these number of stocks are basically purchased or sold by the customers. Clear? Now on 30th of June, again the stock price was $25.79. So basically you can see if you have purchased a stock on 29th of June, so the next day, okay, the next day the opening price was $25.79. So it means again I'm in a profit, right? Then the high price was 30.42. So there was a period of the time on 30th of June when the stock price was reached to $30.42, right? Then after that it decreased to 23.929. Basically again it is much more higher than the previous day. Again the closing price is 23.83. But if you are investing on 30th of June, then definitely you are in loss, right? And if you are comparing the profit that you gained on 29th of June, so if you are investing here, so as compared to the closing price of 29th June, you are in a loss by 0.06 dollar per stock. Clear? Again, there is adjustment close price and the volume is also decreased. Then after that, 1st of January, 1st of July, again the stock price is decreased. Okay. Now the question is how it is increasing and how the stock prices are decreased, right? So if you want to know, so basically there are many decisions. Okay. What is the problem statement of this data, sir? I hope Mr. Abhilash Bachali, you are attending the session, because here it is clearly mentioned that we, with the history, we need to find out why the Tesla stock prices are increasing rapidly, right? In the first line, it was mentioned that Tesla has been on the rise recently with a crazy of 100% five, and with the history, maybe we can find out why, right? So to know why, how to calculate, first of all, you need to understand how the stock market works. Clear? Okay. So basically, how the stock prices are changing or means increasing or decreasing, how we are deciding that. So basically, it depends on how the particular company performs in the market, right? How the particular company is performing in the market. Why? Because if my company is performing well, then definitely the investors will invest the money in my company. Otherwise they will not, right? If they have invested, then definitely they will take their money back. Okay. So how the investors are deciding whether they should invest the money or not. So basically we are making the decisions. For example, if I am running a company, right? So and I have applied for the IPO, right? When I am applying for the IPO, at that time there is a, after the listing, there is a stock prices basically decided, right? Now if any investor, if I'm making any if I'm doing any collaboration with any giant company, for example my company is collaborating with Microsoft, right? So Microsoft is basically has a huge market, right? So they will invest in terms of money, they will invest in terms of technology, right? They will invest in terms of manpower, they can invest in any way, right? But based on that, definitely the market will think that okay, if he is collaborating with any big company, a giant company, right? Or they are increasing anything, means they are going to gain the trust of the customers. Or if I'm launching a new product, for example, there are different vehicle companies are there, right? The Tesla has launched the Cybertruck. I hope you have heard about that, right? Then after that they are launching the electric cars. So most of the companies in the world, first they were basically manufacturing the cars related to diesel and the petrol. Then Tesla comes in the market and they start creating manufacturing the cars based on electric, right? Means electric cars. Now if the electric cars are performing well, right? If the electric cars are performing well, the cost is cheaper, right? They are not harming the environment, right? And it is also fast, right? Durable. Then it is not making noise. So basically, these are the main functions or main facilities that are basically uh, attracting the attention of the customers, right? If I want to purchase such kind of vehicle, right, and I'm thinking about the environment, then definitely I will go for the electric car. But if I'm considering, like in India, if I'm considering, or in any country, if I'm considering the other services that are basically related to that company, that particular car, then definitely I can also like I can make a decision that I don't want to purchase this particular car, right? So for example, okay, for example, they have launched the Cybertruck, like we have discussed about this thing. But if there is a malfunction in the car, first they have created a new car that was not in the market, investor was investing the money and the Tesla price was increasing. But there is the in the news report, right? If there is a malfunctions are reported, like there is some kind of issue with the Cybertruck, right? They are not that much strong, or there is an issue with the electricity, right? So basically, in this case, it means there is some issue, and in that case, the investors, like, they start taking their money back. Why? Because they know now the customers will not invest in their money, and the investors will be in a loss, right? Again, second thing, if I'm making any decisions, for example, if I'm making any particular decision, or if I'm giving any interview, like I think last week or last month, during the time, right, there was Mark Zuckerberg was attending one of the hearing where he was accused about the privacy of the data, right? At that time, the stock market, the stock prices of the Facebook or the Meta company was decreasing. Why? Because there was an allegation on the company, and that was basically a threat to the privacy of the data. Okay, privacy of the data of the customers. So in that case, the customers are not trusting on the company, right? They are giving bad reviews. So basically the investors are thinking that, okay, this company is not performing well. If I am with this company, then definitely I will be in loss. So they are taking their money back. I am a normal customer. Again, if I am thinking that, okay, that the stock price of this company, because of this decision or because of this report, can decrease, then definitely I will always think about my profit, right? So basically, whatever the decisions, whatever the reports, whatever the newly launched products are basically introduced by the companies, right? They make like they impact the stock prices. Clear? So based on that, every company is basically making any kind of decisions. If I'm in a loss in the last day, but during the night I'm making a collaboration, I'm announcing the same thing, and then again investors are investing, then definitely means if I'm collaborating and if the Microsoft is investing in my company, then definitely most of the customers will run to purchase the same stocks, because they know the giant company is backing me, then definitely my stock prices will increase and they will try to gain more profit, right? Okay, so in the same way, here you can see during the first day, $19 was there. Due to some decision, due to some their product, the stock prices was increased and the closing price was 23, right? So if the open price is high, then definitely, and I'm saying in the 90% of the cases, you can assume that the open price will also high. Okay, but I'm not saying 100%. Why? Because if I'm making any decision, or if I'm like if any report are basically released or any kind of issues are there, then definitely my high price can also decrease. If the high price is decreasing, then definitely the low price will be as low as possible, because here you can see $17.5, that is fine. Closing price will also increase, just because the last day closing price was increased and they have not made, they didn't made any decision. That's why here the opening price was high. Due to the opening price, the high price was also high. Then after that, low price was also increased, closing price, and at the end of the day, the closing price was decreased. And just because here you can see there is a decrease at the end of the day, if you are checking in the next day, again the opening price is also decreased. Earlier it was the day before, it was basically $19. Then one day before it was 25.79, and the present day it is $25. Again the high price is decreased, again the low price is also decreased, the closing price is $29.95. So basically, if you have purchased any stock on the 29th of June, so at the end of the 1st July, you are in a profit by $2.95 per stock. Clear? Then after that, if you check here, again it is decreased to $23, right? Again the high price is decreased, the low price is decreased, and again the price is again decreased, and now the closing price is $19.20. Again here you can see on the 5th day the stock price is decreased and again decreased, and it is $16.11. So basically, if I purchased any stock on the 29th of June, so at the end of the 6th July, okay, my stock price is basically $16.11. It means I'm in a loss of $3, approximately $3 per stock, right? But if you check here, right, for the last 5 rows, so here you can see on the 28th of January, the opening stock price was $568. it was increased to 576. Then again the low price is increased, the closing price is basically 566. So basically again there is a loss. But here on the next day you can see there is a spike, there is a high increase in the stock market price due to some any decisions, right? Due to some any product or due to some any positive report. Now the high price is increased, low price is also increased, and the closing price is increased here. Here 632, 640, and the 3rd of February it is 673, whereas the closing price is $780. So if you check from the last 5 days only, so if the opening price was 568, if I'm investing on 28th of January, so at the end of the 3rd of February, right, my stock prices, you can see there is a spike of, there is an increase of around $220 per stock. Okay, so in this way basically the stock market works, right? So basically there are 4 or 5 terms: date, transaction history, open, high, low, close, adjacent close, and the volume. And here you can see what is the difference between this volume and this volume. Clear? So someone, if someone has invested $19, if they have purchased basically, for example, if I'm purchasing a Tesla stock today with the price of $20, but after 10 years if it is $780, then you can see what is the profit, right? So that's why most of the customers, they are investing in the stock market so that they can get the profit in a very short period of the time. Clear? Okay, but before investing in the money, before investing your hard working money in the stock market, make sure to learn how the stock market works. Okay, how to read the graphs, right? How to find out what, how to learn how to read about how the stock market is performing, how to check it, right? How to predict it. Then only you should invest in the stock market. Otherwise, if you are investing just because of some advice given by your brother, sister, or any relative or your friend, then definitely you will be in loss. Maybe they are in profit because they know how to invest, right? How to purchase and how to sell the stocks. But you don't know, right? So first learn about it. Okay. Now we are using df.hit so that we can get the knowledge of first 5 rows, and df.tail is basically giving the information of last 10 rows. Now here we are checking the dimension of the data. So basically when we are checking the dimension of the data, so the number of rows is 2416 rows and 7 columns, whereas the name of the columns in the data set, in the data frame, is basically date, open, high, low, close, adjacent, close, volume, and then after that d type is object because it is representing the data type of the column names that are basically present here, right? Then after that we are checking the minimum date and the maximum date. Why? Because we need to find out whether the stock market data is basically within the given range as per the problem statement. So when we are checking the minimum date, so the minimum date is basically 29th of June 2010 and the maximum date is 3rd February 2020. Okay. Now we are checking the data types, and for that we are using df.dtypes. So now the data type of the date is object, for open is float, and for the volume is int64. Okay, now tell me, you have checked that the date is basically in this format, right? Year, month, and the day. But here the data type of the date column is object. So please let me know whether it is correct or not. I was saying it contains text also, so basically I am not able to find out the text in the date because here it is month, sorry, year, month, and the day. There is no text here. And if we are talking about this minimum date, so basically this minimum date is a comment in the print statement. Okay, so I am concatenating the comment with the output of the function, right? So this is not the valid reason of the text. Okay, sorry, a special symbol dash. Okay, hyphen will make it object and not int. Okay, what about, okay, so most of you saying yes, it is correct, but okay, one of you saying is incorrect. Okay, so let me inform you that those who are saying it is incorrect format, their answers are wrong. Okay, your answers are wrong because the date is not in the correct, okay, data type. Okay, if it is not in the correct data type, then what should be the data type of date column? Please let me know. And please, those who are attending the session, please do not attend the session only for the attendance and only to see the screen. If I'm asking anything, then make sure to answer the questions. Okay, because it will help to improve your knowledge, your information. If you are giving any wrong answer, then definitely I will correct it. But if you are not giving any answer, then it will not help you in any way. Okay, my question is, what should be the data type of date column? Please let me know. Okay, some of you are saying it should be in DDMMYY format. So basically, this is not correct. Okay, the format is not mandatory. Like that, like someone is saying the format should be DD. Okay, someone is saying it is in text because of the dash, that is basically a special symbol present. So basically, your answers are incorrect. Okay, but there are 2 or 3 students are there, those who have mentioned that date or the date time, right? Most of us have mentioned about the date difference, date time. So basically, if you are saying the this should be the data type, right, then your answers are correct. Now my question is, why it should be in the date time format? Why it should be in the date time data type? Because if you are giving any answer, right, then definitely there is some valid reason. So please let me know why it should be in date time format. First of all, you have mentioned that this is correct, right? That was basically wrong. Then date time format, that's correct. Now my question is, why it should be in the date time format only? Okay, so someone was saying because it's a date, so that's why it should be in date time format, but it is not mentioned anywhere that it's a date, right? I can also store the string in the same format. Okay, so the given reason is incorrect because it allows to store both date as well as the time also in a single column. Okay, and you have also mentioned that it is helping to perform the operation related to date. That's correct, right? Because it is stored the date in the standard format. That is also correct, right? For time instant, okay, to it will help to transform data easily. That's correct. To understand by model, okay. Okay, for daytime operation to be used, okay, then only it will be considered as a date, otherwise it will be considered as string or integer or something else, right? It allows to store both date and time also. Okay, so basically those who are saying because your model, right, whenever we are storing the data, please remember that whenever you are storing the data should be stored in the correct format. If you are not storing the data in the correct format, then definitely you will face difficulty to perform the operations based on that particular data. For example, if I am storing the data here as a string and I want to perform some kind of operation, for example, another example is if I'm storing the float values like in the last problem statement within the single quotes, and if I'm trying to perform the operations like multiplication operation or division operation, right, in that case you will not be able to perform, you will get an error because the data is not in the correct format, right? So to perform some kind of the operations, right, the data must be in the correct format. And whenever we are talking about the date time, so the date time format is basically storing the data in a correct format. The format is basically, it can be DD, MM or YY, or YY, MM or DD, right? There are 2 or 3 possible formats are there. It is not mandatory only the DD, MM and YY. Okay. Then after that, along with the date, they are also storing the day, the exact time, and the time is basically in the hours, minutes and seconds, and sometimes it is also storing the data in the nanoseconds, right? Then after that, through the date you can also fetch out the day, you can fetch out the date of the day, sorry, the day of the date, right, and other information. So if the date is not in the correct format, so if you are dealing with any data where the date or the time is basically playing an important role to perform the operation, to do the analysis, then in that case you will not be able to perform those operations, right? Again you have to convert it, right? Because without converting in the specific format, how you can use the related methods, functions or anything? Clear? So doesn't matter you are using a predefined library, because someone is mentioning if we are using the predefined library, then doesn't matter you are using the predefined library or you are using the user defined functions or you are writing your codes, doesn't matter, because if the data is not in the format, then you have to convert it by using the predefined or by using your own code, right? Now so basically here the data type that is basically in the object is not correct, but here we have mentioned that there are 3 different types of the data, that is int64, float and the object present in the data set. Clear? Now we are going to check the null values, and for that when we are checking the null values, we are finding that the date, the open, high, low, close and adjacent columns, basically there are no null values. So here that's why we have mentioned that, as we can see there are no null values present in this data set. Okay, then after that we are using the df.info so that we can get more information about our data set as well as the data set that is basically stored in the data frame. So here you can see the class is basically mentioning the df is basically a data frame here. The range index is 2416, means entries from 0 to 2415. Total number of columns are 7, and here the name of the columns are given and the non-null count values are given, because I received some tickets after the last session where some of you are saying, sir, just because here I think there was some column around 7500 something like that. So some of you are saying, sir, the number of here the values are this much, then why the null values are not showing, right? Because the null values are not there because this is representing the non-null count. It is not giving any details about the null values, right? So basically if I'm saying 2416 non-null values are there, so it means there are 0 null values. Okay, clear? It is not giving directly the information about the null values, it is giving the information about the non-null values, and based on that you need to find out how many null values are there. Clear? And then after that is also giving that date type and all. Then after that, how many columns with the float 64, how many columns with the int64 data type, and how many columns with the object data type. And that's why here we have mentioned that, right? Now again we are checking the heat map so that we can find out whether the null values are there or not. So by using the color representation, here you can see there are no null values. That's why the whole heat map is basically is colored with the same color. Clear? Okay. Now Then after that, we are going to convert our date time, okay, our date time column into the correct format. And for that we are going to use pandas. There is a predefined function named as pd dot to date time. Okay, I hope you have heard about this method. I hope you have learned. Please let me know whether you have learned or not. Okay. Okay. Some of you are saying yes and some of you are saying no. So, are you from the same institute? Because I'm basically 60% of saying 60% of you are saying we have learned about these concepts. But what about the 40%? Okay, yes, but forget, sir. That's fine if you forget that. That's why I have given the whole 1 week so that you can revise everything that is basically discussed by your institute. Okay, so basically, if a majority is saying they have learned, it means uh, okay, it means these are covered, right? Basically, if anyone is teaching about the pandas data frame, then I'm pretty sure that they will cover this library because this is one of the most important libraries, right? So I suggest you please go through the recorded video or the content they have provided, right? And see whether they have covered or not. So basically, two date time is a library, sorry, is a function in the pandas that is basically used to convert the data type from one data type to date time format. Okay, and here that's why here we are mentioning to date time, and then after that first is the name of the column. So here we are writing df dot date. You can either write df dot date, or basically you can, in the other way, you can write this in this way as well. Okay, there are two ways, both are working in the same way. Then after that, format and %y, %m and %d. Basically this is representing the format, means year, month and the day format, right? Then after that, df.info. So after converting, we are storing in the date column in the data frame. And after that, if I'm checking the information here, you can see the data type of the date column is date time 64 and the ns, right? Now it is not in the object format. Clear? Right? So that's why here you can see the date time 64 ns. So it is representing that the data type of your column is now in the correct format. Clear? There is another way. If you want to write a function, you can also use a define function, right? For example, here, okay, only for your information. First of all, we are converting that column, right? If you are not converting, then if you are not giving the format, then by default format is year, month and day. Once it is converted, we are storing in the same column. After converting, after storing in the same column, we are applying dot dt dot year, right? We are using this method on this column so that we can fetch out the year from the converted date time data, right? Here, for example, here the given data is there. First of all, either you can use this way or you can use the other normal methods to fetch out the information, right? For example, from a date, from the time, from a date, that is basically with the date. If I want to fetch out some information, like I want to fetch out the month, I want to fetch out the year, I want to fetch out the time. So in that case, there is a predefined function that is dt.year, which is used to fetch out the information, which will fetch out the year from the date. If you are using dt.month, then it will fetch out the month from the date. If you are using dt.day, then it will fetch out the day. For example, today is 16th of March, right? So it will fetch out the 16th of March, right? 16th as the output. Then day of week, right? What is the day? 1, 2, 3, 4, 5, 6, 7, right? Then after that, we are dropping the this column, the date column from the data frame, so that there should be no duplication of the data, because the same data will be present. Like you are fetching out the date, day, year, right, month from a single column. If you are storing in different column, it doesn't mean that the data is removed from the original column, right? So that's why it is important to remove the original column, okay, so that there is no multicollinearity issue. Clear? Yes, that's why I mentioned that if you want to split, you can split it, right? But you have to write the code, right? You have to use the split method, or if you want to based on some other logic, you can do that. It is not mandatory to use this method, but just because this is a predefined method, right, you can use it very easily to fetch out the information. But if you want to write the code, if you are able to write the code, then that is basically most important thing, right? Because for every kind of problem statement, predefined libraries are not present, right? So in most of the cases, you have to write down your own codes, right, Vijay Kumar? If you're able to write, then that is basically that will give I can say what one point to you, right? Because in the interviews, if you are able to write the code, then definitely you have more chances to get placed. Okay, please remember that, because others are using the predefined libraries. If the predefined libraries are removed, then they will be helpless, but you will be able to write down your own code. Okay, now then after that, after converting the column into a date time format, we are setting the index, right? And to set, why we are setting the index? Because we want to make the date time column as our index. Basically in our data frame, there is a index is present, that is basically here 24112412 or 01234. That is a default index value, right? But here, just because here my date is basically representing the relevant trading day. For example, if I want to fetch out the information for any particular day, I want to fetch out the open, low, high, close price, right, for a particular day. In that case, I have, if I'm using the log method or ilog method, right, or any other method, then but if I want to fetch out the information based on the index values, then in that case I have to pass this one. And it is very difficult for me to remember the index value of each date, right? So what we can do, we can set the existing data, okay, existing column as my index of the data frame. Clear? So for that, what we are using the set index method. That is again a function of the data frame, and here we are using df dot set index and date, and then in place is equal to true, in place is equal to true, so that the same operation must be reflected on the original data frame. Whatever the changes we are making, it must be applied on the original data frame, right? Then after that, we are checking the data frame. Now here you can see the alignment, right? Here you can see the position of the date and the remaining columns. It means now the date is not a column of the data frame. Please remember that. Now the date is not a column of the data frame, it is the index of the column, okay? Because the default index, that is basically starting with 0, has been removed, okay, has been replaced by the one column that was a part of your data frame, right? So here you can see in the data, but remember that whenever you are replacing the existing or the default index value, then the column that you are using, the data that you are using, must have all the values as the unique value, okay? Otherwise you may face errors, right? So here you can see for the date, all the values were unique. Now the date is my date column is not a column, it is an index of my data frame. And if I want to fetch out the information for 6th of February, for 10th of June, right, then I can directly pass the date, and I will be able to fetch out the open, high, low, close, adjacent, close, and the volume information for that relevant trading day. Okay, sorry. After setting the index, if you check here the dimension of the data, now the dimension of the data has is changed. Now earlier there was 2416 rows, it means the number of rows are same, but there were 7 columns, but now there are 6 columns. Why? Because the date is now set as the index of the data frame. Clear? Mangal Adhav, I have just explained, right? I took around 5 minutes to explain why we are setting the date as the column, right? I cannot repeat it again. So please watch the recorded video, right? Otherwise, if I'm explaining another part, then definitely you will be able to understand. Okay. Now, then after that, now we are going to check the unique values. So for that, I can use df.nunique because the nunique method is giving the number of unique values present in a data frame. Now here, if I'm checking, I am converting the data frame. So here in the open column, there are 2132 number of unique values. For the high, 2128. For the low, 2136. For close, total number of unique values 2225. For the adjacent close, the number of unique values are 2225, and for the volume the number of unique values are 2391 out of 2416 values. So here if you check here based on these stats, so you will be able to find out that the number of unique values, there is a very less difference between the number of unique values and the size of the data set. Clear? So here the size of the data set is basically 2416, but the number of values, unique values in all the columns are basically more than 2000, right? Now, then after that, we will use the for loop that will iterate over the df.column so that we can check the count of each unique value in every column. For example, here I'm using the for loop. I is the iterator that will iterate over the df.columns, right? Then after that, here df.column.value count function. Value count function is to count the frequency of each unique value in a column, right? So here, just because here we are applying on the column, that's why here you can see there is no information about the date is mentioned. Why? Because now date is an index, right? Date is an index, not a column. That's why the value count function is not applying on the date column. It is starting from the open column. Now here you can see there is a value that is 30 in the open column that repeated maximum number of times, that is 6. 28 6 times, 28 5 times, 220 5 times, 364 times, and so on. And what is the length? The length is basically 2132. It means the total number of unique values in the open column is 2132, and here you can see the same number of unique values, right? Now in the high column again, the 34.5 and 28 and 30 are repeated same number of times, that is basically the maximum number of times, and the maximum number is 7 times, right? Now 225 1 1 1 1 1, and the length, that is total number of unique values, are 2128. Clear? Now in the same way, the low column, in the low column the maximum number of times that any value repeated is 6, and there are two values, that is 27.29 and 28.0. What is the total length? The total length is 2136, right? Now for the close, there are the maximum number of times, basically 27.42 repeated maximum number of times, and the frequency is 4 times, right? Then after that 20.7199 3 times, 27.123, 26.53 times, 219 3 times, 233 1 time, 237 1 time, and 780 1 time, and total number of unique values are 2225. Okay, now for the adjacent close column, again here 27.42 repeated maximum number of times, that is 4. 20.71 3 times, 27.12 3 times, 26.50 3 times, and 240 233 237 728. The total number of unique values are 2225. Now the last column is volume. In the volume, the 986,300 repeated maximum number of times, that is 2, and here the frequency of the 2 is more, right? The total number of unique values are 2391. Clear? Now okay, now now here you can see, if you check here, if you check these two columns, first one is close and second one is adjacent close, please let me know what you are able to analyze between these two columns. What is your analysis based on this data? Okay, based on this data, what is your analysis about the close and the adjacent close? Please let me know. Some of you are saying, okay, both are look similar, both columns are same, both the values are same, value in the both column is same, both giving same information as, okay, values are same, both columns have the same data. Okay, so most of you are saying in the both the columns the values are same, right? So what we should do in this case? What we should do in this case? Okay, Kirti and Chandan and Vijay, your answers are correct. Okay, what about others? Okay. Okay, Kunal, your answer is also correct. What about others? Okay, and okay, so you are saying we should keep only one column and we should drop the another one. Now my question is, why we should drop the other column? Just because the data is same. If the data is same, then what is the problem here? If the data is same in two columns, then what is the issue here? Okay, so Bipul Anand, what is the problem here? Okay, Kirti, you are saying there are no issue, sir. I think okay, that's fine. What about others? Avilas Bachali, you have already given the answer, and your answer is correct, right? Okay, we have to consider one column if both are same, but that's fine. That's what I'm asking. You are saying you should keep only one column. Again, I'm saying okay, I agree with you, but what is the valid reason behind this one? Because if you're saying we should keep only one column, right, we can have same output twice, then what basically this is not our target variable. I hope most of you are not aware what is our target variable. I'm pretty sure about it. Publishing, you are saying we can create data frame, and what is the use of creating a data frame here? Please let me know those who are saying they can give the same output data or they can create something. What is the reason behind to drop one column if the two columns have the same data? Bipul Anand, your answer is correct. Okay, someone is saying count of values is increased. That's why we did not get the correct answer. Harsat Park, your answer is incorrect. As it will impact on the result outcome. Okay, there should not be duplicate columns in data set. That's fine. If you're saying duplicate means same data, right? But I am asking if the duplicate or the same data is present in the data frame, then how it will affect? Why you are saying we should drop it? What is your observation? What is the main valid reason behind dropping a column if two or more than two columns have the same data? If both the data are same, the output will remain same, then only one data frame is enough. Okay, it will increase the processing time, and we are not worried about the processing time. If we are worried about the processing time, then the data where the number of columns are in thousand or in hundreds, we should drop all the columns, right? We are not worried about the data processing time, because our main aim is to achieve the problem that is given in our problem statement. That's fine if it is consuming the space and memory. I'm not worried about the space and memory, right? I really want to if I'm really worried about the space and the time complexity, then I should reduce the time complexity and the space complexity of my code. Okay, because if your code is not written properly, then doesn't matter what is your data, your code will take sufficient time to execute the code, or to it will consume more memory. So we should focus on the coding part, not on the data part, because if the data is relevant, definitely I will keep it. Any another reason? Okay, you are asking about how decrease the how decrease the time and the space complexity. Kirti, this is a whole different part. Okay, you have to learn about the algorithms and the complexity part, right? I cannot teach you here how to check the space complexity and the time complexity. Okay, that is a different part in if you are learning about the software engineering, right? If you are uh, applying for the developer part. Okay, but just because you want to become a data scientist or the data analyst, so you are not going to write that much code, right? And you should not be worried about the developer part, right? Okay, so basically those who are saying it will perform overfitting, it will create biasness, right? So the most important thing is it will create the multicollinearity. Okay, it will create the multicollinearity issue, because the multicollinearity is when the both, if the two or more than the two columns, right, are highly independent or similar to each other, right? So they will create the multicollinearity issue, and we always try to reduce it. It is not because of the same data or something like that. If you're saying the same data, then always give the valid reason behind your answer. If you're not able to do that, then definitely it will not help you, right? Some of you have mentioned about the multicollinearity issue, right? So we will drop one column. Okay, before that, most of you are saying it will give this output. Now my question is, what is the target variable of this problem statement? We have learned about so many things, right? We have learned how the stock market works. We have learned about so many things about the data, about what kind of the data is there, right? Now my question is, what is the target variable here? Because here the target variable is not given straight like there directly. So basically here it is bit tricky to find out the target variable. So please let me know what is the target variable of our problem statement. Because before dropping any column, you must know what is your target variable. Okay, someone is saying, Nima, your answer is correct. Vijay Kumar, your answer is wrong. What about others? What is our target variable here? Kirti, you are saying target is whether stock will go down or increase, but how will you able to find out that? Because this is not an unsupervised machine learning problem statement, right? This is a supervised, and in the supervised machine learning problem statements, the target variable is present in the data set. Now my question is, what is the target variable in your data set? Please let me know. Okay. Some of you are saying volume traded. So basically, why the volume traded is can be your target variable. What is the reason behind it? To understand the clearly, okay, why the volume should be your target variable. Someone is saying raise in price. Okay, more is the trading, more is the demand of the share, and the demand of the share does not. I think it is impacting, but not that much impacting the overall price of your stocks, right? Because if the stock price if the price of my stock is 1 rupees and you are purchasing 100, right, then I don't think it will impact much more on the price of my stocks. More is the trading. Okay, sir, we have to find out why suddenly change of our share values. So that's fine. But how you will be able to find out? Because the data is given, the limited data is given here, right? The limited data is given there. And for example, if you are um, investing in the market, then how you're deciding based on the number of volume? I don't think you are investing based on the volume. Ritu, your answer is correct. Okay, I have received around two or three answers that are basically correct. But again, the question is how you are going to decide it. Because see, if you are investing in a stock market, right, we are not investing based on the stock, the volume of the stock that are basically in a particular day. We are not investing based on that. Okay. The next question is, how will you be able to find out whether you are in profit or in loss? Okay, by comparing purchase value and the current value, right? Difference between the opening and the closing value, right? Because only closing column we understand the profit or loss of the day. So basically, if you are saying based on the difference between the opening price and the closing price, right? Then at the end of the day, the only thing that is basically explaining whether you are in profit or in the loss, that is your close price. Okay, not the opening price, because opening price fluctuates based on different thing. But if you are really thinking about whether you are in profit, because whenever we are checking the data, we check whether the Sensex, what was the closing price of the Sensex, right? Because opening price can be anything. And see, if we are checking the stock market, right, before opening the stock market, the price is different. But when the stock market opens, at that time, the price is different. Okay, so if you are really want to find out why a particular stock market is behaving, like whether it is increasing or decreasing, we always focus on the closing price, right? Because opening price can be anything. And those who are saying volume is basically not affecting the price of a stock that much, because if I'm selling, right, if I'm selling the stock market, because I know the price of the stock market can decrease, in that case your transaction will be increased, the number of stocks will be increased, like the volume of the stock, because we are changing, right, we are selling or we are purchasing, but it is not defining the price of your stock. So the closing price of the target of the stock is basically deciding whether your stock is in profit or in the loss. Doesn't matter what is the highest value, doesn't matter what is the lowest value, doesn't matter what was the opening price. At the end of the day, the only thing that is basically uh, deciding whether you are in profit or in loss, how the market was working, whether the company will behave, will like the stock price of the company will increase next day or not. 90% it is based on the closing price. Okay, for the 10% there will be different factors. Okay, the volume will be high even if the share getting sold in bulk when the price is dropping. That's why I'm saying the volume is not your target variable. Here the closing price is your target variable. Clear? So here it means there are two closing column, close, and the adjacent close, right? So we can drop any one of them, because there is a, in both the column the exactly same data is present, and that's why it is creating the multicollinearity issue, right? Just because it is creating the multicollinearity issue, and to avoid this, what we will do, we will drop one of the column, and for that what we are doing here, we are dropping the adjacent close column, because here the adjacent close column, it should basically consider the other points, right? But just because after considering everything, the data, means the data that whatever is present in the adjacent column is exactly same as the closing price, then in that case the adjacent close column has no use, right? So we are dropping it, and the close column is our target variable. Clear? Now again we are checking the df dot head, and here you can see the values are there. And now the size, if I'm saying what is the dimension of the data, now the dimension of the data is 2416 rows and 5 columns. Only 5 columns. Why? Earlier it was 7. One column is basically set as the index of the data frame, and one column is removed, right? So the remaining size of the data set is 2416 rows and 5 columns. Clear? Now we will check the duplicate values in the data frame, and for that we are using a function name that is basically duplicated, df.duplicated.sum. Duplicate data means the exact data, means the data in two different rows are exactly same, then it is considered as the duplicate data, right? So if we are removing the data, if we are removing the duplicate or the same data in the column, so we also remove the duplicate data from the rows as well, right? So if in two rows the exact data is present for all the columns, then in that case we drop the duplicate rows, and for that what we are checking here, we are checking the df.duplicated.sum, and here the total number of duplicate rows are 0. Clear? If the total number of duplicate rows are 0, so we are not going to drop any row, right? Now we will check the, we will check the summary of the data, and for that we are using the describe, because the describe method is giving the statistical summary of your numerical columns. Numerical column means where the data is present in the numbers. It can be your integer value, it can be your float value, right? Now here you can see the count of the columns is basically 2416 for all the columns. It means there are no null values are present. Clear? the mean of the data means average, right? The average of the data for the open column is 186. For high it is 189, for low it is 182 and 186 and 557 and so on, right? Now the standard deviation is 118, high value is 120, here 116, 119. Minimum value, that is basically the lowest value for the open, was 16.13 for any particular day. The highest was 16.62, the lowest was 14.8, and the closing price was 15 as well, right? Now the 25 percentile is basically first quartile of the data, that is 34, 34.84, 89, 33.53, 34.40, and here the values are different, right? 1889 point something something, right? Then second quartile or the 50th percentile, that is 213.035, 216.745, 280, 212. Then the third quartile is basically 266, 270, 262, 267. And the last one is the maximum value. Here the maximum value for the open is 673. So if you check the difference between the minimum and the maximum value, you can see the how the open price was basically increasing in the last one decade, right? Now here the high price was 16, but if you check the highest price, it is basically 786. So the difference is around $770 per stock, right? In the same way, the low, right? In the low, what is the minimum value and what is the maximum value? In the same way, here the closing price, the lowest value was basically minimum value was 15 and the maximum value was $780, right? Now what is our observation? This basically whatever the graph we are checking, this gives the statistical information. Statistical means it is giving the count, mean, standard deviation, minimum, 25 percentile, 50th percentile, sorry, second quartile, third quartile, and the maximum value, as well as we can also fetch out some other data, right? Now from the above description, we found out that there are no null values. Why? Because the count of all the columns are same. Now we are checking the mean, minimum, and the median, right? So in the if we are checking the, sorry, if we are checking the mean and the median, then we will find out that the median is high. Median is basically this one, 213, 216. Basically the median is high for all the columns, right? Okay, for 2013, okay, for all the columns, like for open, high, low, close column, it means the data in open, high, low, and the close are basically skipped to left, means there is a left skippedness present, right? And then after that, if we are checking the difference between the third quartile and the maximum value, means third quartile is 266.45. What is the maximum value? It is 673. The difference is around 400. Here the differences are more than 500, right? The difference is around 400. Again the difference is more than 500. It means we can say that, okay, there are outliers that may present in the open, high, low, and the close column, right? Then after that, we can also check the standard deviation. What was the minimum value? What was the first quartile? What was the third quartile? And so on, right? We can also find out for the outliers by taking the difference between, please let me know how we can find out the outliers. Okay, by checking the mean and median, basically. Okay, by plotting box plot, that's correct. But some of you are saying by mean and median, basically the mean and median is used to define the about the skewness, right? Not about the outliers. If you really want to find out the outliers, then you should check the difference between the mean and the standard deviation. Okay, you can also plot the box plot, that's correct, but I was asking about this data. Clear? Okay, then after that, if you want to use the heat map for the describe method, then in that case, in the heat map you can use the describe method, and not is equal to true, so that we can see these numerical values on the color graph. FMT is equal to 0.2f. It means if we want to check, sorry, it will allow only two values after the decimal point. Line width is 0.2, line color is black, and the C map is spectral, right? Now then after that, we are giving the label name, that is basically here figure, and for the Y labels we are giving the feature names, right? And the title is basically descriptive graph, right? So here you can see the same information is present in the color coding format. Okay. Or we can use the log transformation or power transformation to keep outliers as the data is valid. See, basically, Abhilash, I'm going to explain about this part, right? Whether we should drop the column, whether we should drop the outliers or not, right? But before that, let me complete the other part, right? Okay. Then after that, we are moving ahead for the graphical analysis. Okay. Now, anyone can please tell me why we are using the LM plot? I hope you have heard about the LM plot. Please let me know. Okay. You are saying you have not heard about the LM plot. Okay. Anyone have heard about the LM plot or not? Mm-hmm. Okay, Abhilash, you are saying it is covered, right? Okay. Okay. Okay, so again, most of you are saying like Chandan, Kunal, Abhilash, you are saying it is covered. Okay, that's fine. So basically, whenever we are talking about the LM plot, basically LM plot, it is a plot that is created by combining two different plots. Yeah, a scatter plot with overlaid regression line. That's correct, right? So basically, no, it is not a scatter plot. Basically, whenever we are talking about the LM plot, then it is combining two plots. First one is a reg plot that is known as the regression plots, right? So that's why someone has mentioned that the scatter plot with overlaid regression, right? So basically, it is a combination of the reg plot and the facet grid, right? Now, what is facet grid here? Facet grid is basically at different points, it is checking the scattering, right? It is checking the scattering of the data. That's why we are using it is a combination of facet grid and or it is combining the facet grid and the regression plot. Why? Again, because the regression plot is used to give the best fit line, right? Which will find out whether the data is in a like whether the data is changing, means what is the relation between the two columns. If we are making any changes in one, then how it is affecting the other one. Now the second one is facet grid, because the facet grid is basically used to map the data on different conditions, right? So that's why we are using the facet grid here. Clear? So LM plot is a combination of regression plot and the facet grid. Clear? Okay. Now, so here we are using the sns.lm plot, and here in the x column we are taking the open, and in the y we are taking the close value. Data source is df and the palette means the color code is color bright. Now, if you check here, the open values are basically from the 0 to 700, whereas the closing price is basically from the 0 to 800 plus. If you check here, so basically this is a best fit line, and this best fit line is basically coming because of the regression plot, and here you can see all the data points. Please wait a minute, okay? Please wait a minute. Just give me 1 minute. Okay. Okay, scatter plot. Hi, so I will be on leave for work now. I will catch up for rest of the session. So basically, I'm not your SME first of all, but if you want to leave the session, then that's fine. But make sure to attend the session from the next time. Okay, and you can watch the recorded video of the session, right? Okay, so basically I was explaining about the LM plot. So basically in the LM plot, we are combining two plots. First one is rect plot and second one is scatter facet grid, right? Now here you can see there is a one straight line. Okay, that is basically representing your best fit line. If you have learned about the regression plot like linear regression, then you are well aware about what is the best fit line. Now the second one is the facet grid, right? Because of the facet grid, based on the different conditions, based on the different data, here the data is scattered, right? And here you can see that there are all the data points are basically scattered around the best fit line, and there is only one data point that is far away from the best fit line. Now by observing on the best facet grid, we can find out there is a strong positive relation between the open and the close column, right? Why? Because all the data points, I'm saying almost all the data points are gathered around the best fit line. Now that's why here we have mentioned that open has a positive correlation with the close. Now in the same way, if you are checking for the SNS.lm plot, right, x is equal to low and y is equal to close, data is equal to df and palette is equal to color bind, right? So in that case, if you check here, so again here the data point is basically more closer to the best fit line, and here we can see that okay, there is a more strong positive correlation between the close and the low column. So by looking on these two graphs, we can find out that the and the open and the low columns are important for the close column. It means if there is a change in the open or the low column, then there is a change in the close value of the stock, right? Now then after that, we are checking between the volume and the close, and when we are checking between the volume and the close, we are finding out this is the data point. The data are gathered, right? But here by looking on the scatter plot, you can see there is a positive relationship, but not a strong positive relationship, right? Positive relationship means if we are making changes in one data, then in the same way, right, if we are increasing the data, then the data is increasing in the other column. If we are decreasing, then the data is decreasing in the other column, right? So there is a positive relationship, but not the strong positive relationship. Clear? Okay. Now SNS.lm plot, x is equal to volume, y is equal to height, and data is equal to df. Now we are checking between the relation between the height and the volume. If we are checking here again you can see that this is the best fit line, and most of the data points are gathered around here, right? Most of the data points are gathered here, and some data points are gathered different places, right? By looking on this, we can find out okay, there is again strong relationship, right? Sorry, there is a positive relationship, but not the strong positive relationship with between the high and the volume. Okay. Okay, someone is saying, sir, you have mentioned about the correlation. Basically the correlation is a parameter which is used to find out the relationship between the values, and I have already discussed about the correlation parameter in the last project discussion session. I hope you have remember about the multicollinearity, right? Before the multicollinearity, I have discussed about the correlation, about the different parameters of the correlation, right? Okay. Now then after that, here I am using the plt dot figure fig size, that is basically defining the dimension of the data in inches. Then after that, p is equal to 1, I'm initializing a variable with the value 1, and then after that I'm using a for loop that will iterate over the df, right? Df means my data frame, and here I have given one condition, that is if p is less than equal to 17, I am giving any value, right? It is not mandatory to give 17, you can give any value, but it should not be less than the number of columns, right? So p is less than equal to 17. If this condition is satisfied, then we are using the subplots, and the dimension is 5 rows and 4 columns, and then after that the current value, right? So by basically why we are using the subplot, so that we can plot number of graphs in a same structure, means same figure. Clear? Now here sns dot rect plot and x is equal to close means we are using the reg plot between the close and y is equal to y means for the each iteration of the data. Data is equal to df and color is equal to r. On the x label, we are giving the close as the name, and on the y label means on the y axis we are giving the current iteration value, right? Means the name of the column, that is basically the current column for a loop. Now here if you see here, so basically the reg plot, okay, the reg plot and the output of the lm plot is same. The only difference is there, this aura, right? Here you can see there is a case here, right? So basically the facet grid is working as a subplot here, but based on some condition it is finding out the relationship. In the reg plot it is directly giving the relationship between the two columns, and there is a best fit line, but there is no condition. That's why there is no graph of this one, right? Clear? Now if you check here again, I'm applying the reg plot. I'm going to use one more plot so that you can find out the similarity between different kind of plots, right? For the same output you can use different kind of plots. It is not mandatory to use a single graph. You can use any number of plots. Again I'm saying, on the same data, and a same plot can be used on different kind of data. So basically here if I'm using the reg plot, I'm getting the same output. What is the output here? Means I am finding out the relationship between the open and close, high and close, low and close and close, right? And then after that volume and close. And after checking on this, if you check here the relationship, if the check the data point, all the data points in the close versus close on the best fit line, because both the data points are same, means we are finding out the relationship within itself, right? If you check here between the close, so here you can see, okay, here if you check, so here you can see the positive, strong positive relationship, strong positive relationship, strong positive relationship, but here there is only a positive relationship, right? Now if I want to use the scatter plot, I can use the scatter plot as well, because here the regression plot is not there, but again it is giving the information about the same thing. Okay, the use of a best fit line is how well the data is basically in the same line, right? But if you're talking about the scatter plot, reg plot, lm plot, all the plots are giving the same information about, means about the relationship between the features, right? That's why here I have used the lm plot, then I use the reg plot, then I am using the scatter plot. Again here you can see there is again the very small difference, means it is giving the scatter plot, it is using the scatter plot so that it can find out how the data is gathered, right? And what is the relationship between the two features. But here the regression means your regression line or your best fit line is not present here. Okay, again there is the same output. So from this feature we can identify all the features except volume have a positive linear relationship with the target variable, means with the close variable, because we are plotting the graph between the close and the remaining columns. Clear? Okay, now then after that we are doing the multi-collinearity graph, and for that we are using the sns dot pair plot. Data is equal to df, palette is equal to dark, right? And just because I have mentioned about the in the last session, the pair plot is basically used to find out the relationship pairwise. Okay, pairwise means it will find out the relationship between one feature with the other feature, and it will create a pair, means it will find out the relationship by creating a pair between the features. So here if you check, it is finding out the relationship between the open and open. If we are checking here, so between, it is not finding out the relationship, it is finding out the distribution of the data. That's why diagonally you will find out the distribution of the data, how the data is gathered here. So if you check here, so here you can find out, okay, the data is basically left escape. Now it is finding out the relationship between the open and the close, sorry, open and the high, open and the low, open and the close, and open and the volume, right? In the same way, high is giving the information between the high and the low, right? Sorry, high and the open. Then it is finding out how the data is distributed in the high column, then high and the low, high and the close, and high and the volume, right? Again, in the same way for the low, for the close, and for the volume. If you check for the volume, then the volume you can see there is a positive relationship with the open, high, low, close, but not strong, and how the data is distributed here, right? Now, what is our uh, observation here? The pair plot gives the pairwise relationship between the features. On the diagonal, we can notice the distribution of the data, means how the data is distributed, and the features low, open, high have strong linear relationship with each other, because from all the graph you can see close is highly correlated with open is highly correlated with low, low is highly correlated with high value, right? It means these four columns are highly correlated with each other, means there is a strong positive relationship. Clear? Okay. Now then after that, it is all about the how we are checking the information about the multicollinearity and the about the multivariate analysis and the bivariate analysis. Now we are moving ahead and we are plotting one more plot, that is plt dot figure, and the fixed size we are defining here, right? Then after that we are using plt dot plot. Please remember that here we are checking the plt dot plot, and here we are giving the df dot close, right? And the label is closing price. On the Y label, we are giving the stock price. X label, we are giving the time, and the title is stock Tesla stock price. If you check here the graph, then you will identify here we have on the Y axis, we have given only the closing price, but on the axis, on the X axis, we have not given any information, but it is giving some kind of information, right? Those who are investing, right, in the graph, sorry, those who are investing in the stocks, they are well aware how this graph works, right? Please let me know, those who are investing in the stocks, have you ever seen this kind of graph? Okay. And what is the use of it? What is the use of this graph? Correct. Okay. Now, someone was saying, sir, why, few minutes back, someone has asked why we have used the date as the column, as the index of the value. So basically, if you check here, as per the graph, I am using the plt dot plot. Plt dot plot is basically is creating a line plot here. Okay, it is creating a line plot, and the line plot here it is creating between the close column and the index of the value, and here in the index value the time is given. Okay, the time is given, so basically it is creating a line plot about how your closing price works, means sorry, how your closing price was behaving, or how it was changing over the period of the time. Period of the time means from 2010 to 2020. And here you can see for the closing price the graph is between 0 to 800 plus, right? Now if you check the closing price here, I can say in the mid of the 2010 the closing price was around $20, right? Because here the graph is basically here it is the difference between the points is 100, right? Basically here in the mid of 2010 the price was around basically 19 or $20 that we have already checked. Then after that it is decreased, and at the end of the at the last quarter of the 2010 there was a slight increase in the stock price, in the closing price of the stock. Again it was same, right, till 2013, the first quarter of 2013. After that here you can see there was a sharp increase in the price, and it reached around $120. From 20 or $25 it increased to $120. Then again it was decreasing, decreasing, and at the end of the third, means at the end of, or you can say at the third quarter of the 2013, 13, again there was a decrease in the closing price. Again it was increasing, then decreasing, right? Again increasing here, then decreasing, right? Then after that, here in the 2016, the closing price was decreased. Again sharply it is increasing, then decreasing, right? Then after that, but here in the 2019, during the first or second quarter, here you can see the stock price was around $200, right? But after that there was an increase, then decrease, and here you can see at the end of, means the third quarter, the stock price of the Tesla stock was increased and it raised to around $800. Means there was a stock price, right? So basically the line plot is used to find out what are the ups, what are the downs, means how the stock prices are increasing, how the stock prices are decreasing over the period of the time, right? So those who are investing in the stock market, they are checking such kind of graphs so that they can find out any particular value, what is the open price, low price, means you can check for anyone, right? There are filters, you can use the filters to find out how the open price is behaving, how your closing price is changing, right, over a period of the time. And based on these analysis, we are finding out we are making the decisions. Clear? We are making the decisions. Yeah, Abhilash, your answer is correct. It gives the information of the price with the time, right? Means how your price is changing over a given period of the time. Even if you are using any particular of application, they are also using one more plot, that is basically candle plot, right? They are also using whiskers plot. They are also giving the options so that you can find out the information, right, about the particular day and the time, right? Instead of using the whole data, you can find out the how your price is basically changing, right? Information of the price for a particular day, for a particular hour, for a particular month, and for particular year. Clear? So that's why here we are using the line plot. Then after that, if we want to find out more, then in that case, here earlier we were using the PLT, means matplotlib dot plot. Here if you are using the SNS dot plot, means in the Seaborn the same plot is present with the name of line plot. Here what we are doing, here we are using data is equal to df.ilog. I am using the ilog function so that I can select all the columns except my last column, and in the last column my volume data is present, right? So here I'm selecting all the data except my volume data to find out how my data is behaving, right? So here basically in the stock value there are four values are there: open, high, low, and the close, right? The close are basically represented by hyphen and the dots. Low is basically dots in green color, high dotted line, and open is basically present with the straight line of in blue color, right? Then after that, plt.y label, in the y label y axis we have given the name stock value, or and the title is the general trend of all values, means how the open, high, low, and the close are behaving, right? How they are changing, what is the information about these four terms over the period of the time, means from 2010 to 2020. Clear? Now if you check here, if we check basically this graph is blurry. Why? Because the size of my screen, right? But if you want to what plot the graph for each value separately, then you can do that. But here if you're checking here, so by looking on this graph I can find out that, right, I can find out that all the values are basically behaving in the same way. So right, if you check here, all the values, what doesn't matter if the stock price is increasing, if the open price is increasing, then the low price is also increasing, then my closing price is also increasing. It means all the data points are basically, so all the values are basically changing in a same way. So here if you check at the end of the graph, right, here at this graph, if you can see there are only, after this extent, there are only two values are there. That is, first one is in the orange color and the second one is red color. And if we find out what are the values, so basically here the high value and the close value, it means at the end of the 2000, like at the first quarter of the 2020, after some this extent only there are two values are increased, that are basically closing price and the high price. Clear? So basically this graph is used to find out the relationship, sorry, this graph is used to find out how the specific values are changing over the period of the time. Clear? Clear? Okay. Now after that we are going to check the box plot so that we can find out the outliers. Okay, we can, now we are going to check the outliers to find out the now we are going to use the box plot to find out the outliers from the data, and for that here we are using the box plot. And if you check the output for the open price, there are some outliers because this is the minimum value, first quartile, second quartile, third quartile, and the maximum value. So you can see there is a less difference between the first minimum value and the first quartile, but there is a huge difference between the first quartile and the second quartile. Then after there is huge difference between third quartile and the maximum value, right? And then after that the data points that are basically present outside the minimum value and the maximum value, that is considered as an outlier. So here if you can see, these are the outlier. In the high column outliers are present, in the low column outliers are present, in the closed column outliers are present. Then after that in the volume, number of outliers are there, right? Now the question is whether we should drop the outliers or not, because someone has asked that maybe sir the outliers are present, this is the real time of the data. That's correct, right? See, whenever you are working on any data, first of all you must have the knowledge about that particular domain, right? For example, if I am working on the stock prices, then first of all I should know how the stock prices works, right? How the values are changed, how the values changes, right? What are the different parameters, how they are affecting that. Then after that we should do the analysis. Based on the analysis, again we should make our observations. Based on our observation we should make our decisions, right? So basically if I am saying the volume, it basically whatever the outliers are present, that are not correct. That can be correct, right? Because in the real time there are many companies where the volume can be any number in real time, right? Then after that in the open price, the prices can change anytime, right? The high price can change anytime, the low price can change anytime, the close price can change anytime, right? Basically if we have the domain knowledge, then we can say that okay, whatever the outliers are given here, that is basically because of the limitation of the box plot. But in real time, okay, in the real time these data points are not outliers, right? So what we can do, first of all, if you have the domain knowledge, then you can decide that. But again I suggest, instead of making your observation based on some partial information, you should do two things. First one is remove the outliers, right? Train the model, check the performance of the model. In the second case, do not drop the outliers, train the model and check the performance, and you will be able to identify how the outliers are affecting, means the outlier that are coming in your box plot is affecting the performance of the model, right? If there is a huge difference between these two cases, then it means the outliers are affecting. Then after that, if you are saying okay the outliers are affecting, now you need to find out whether this particular kind of the data are outliers or not. Because the outliers means, if you see the definition of the outlier, it means the data that is far away or that is far different from the remaining data is considered as an outlier, right? So the data can be different. For example, if I am talking about the temperature, in the current scenario the maximum temperature is basically 50 or 55 degree. But if the temperature is increased to 100 degree in for a particular day, in that case this is an outlier. But if we are checking the boiling point, right, 100 degrees Celsius, 200 degrees Celsius, right, or we are checking the temperature of another thing, then in that case that is not an outlier, right? So first of all you have to check the domain, right, and based on that you need to find out whether the particular data point can be an outlier or not. If it is an outlier, again you should train the model in two ways. First one is we should consider that outliers as a outlier and we should drop them, and we should then train the model and check the performance. In the second case, do not consider that point as an outliers, right? Do not drop the outliers, build the model and check the performance. So basically these are the two cases, clear? And you cannot make any decision blindly. Whenever you are making any decision, first of all you should do the analysis, you should perform the task, check the values. If the values are satisfying your decision, then only go with any one case, clear? Okay, now so here for example I'm considering myself as I don't have any knowledge about the particular domain. So in such cases we should drop the outliers, right? If I'm considering I have the knowledge, then I have to follow the two cases, right? But just because this is a project discussion session and I'm telling you how to drop the columns, how to drop the outliers, so I'm considering these outliers as an outlier and I'm going to drop them so that you can learn how to treat the outliers, right? But in real life you should make the models in two different ways and you should check the performance of the model, right? Now, so after checking on the data points, we find out that there are outliers in the open, high, low, close, and the volume, right? Now we will drop it, and for dropping the outlier, there are multiple values. But the most, okay, the most popular methods are Z-score and the IQR method. The IQR method is basically working in the box plot, and there's one more parameter, that is Z-score. And in the Z-score what we are doing, we are making a threshold value. Means the threshold value, it is basically considering the deviation value, right? And from -3 to +3, it is considered that after doing the mathematical calculation and the research, right, it is proved that 99.7% of the data comes under the graph in the range of -3 to +3 deviation point, right? So that's why we are considering the 3 as the threshold value, right? If any data point that is basically present far from -3 to +3, it is considered as an outlier, right? So how we can drop here, how we can treat the outliers here? Okay, so what we are doing here, first of all, we are importing the library that is from scipy.stats, and we are importing the Z-score library, right? Z-score method. Now then after that, what we are doing here, okay, just tell me one thing, whether we should detect the outlier from the target variable or not. Please let me know. Please let me know whether we should detect the outliers from the target variable or not. Some of you are saying yes, some of you are saying no. Correct, Abhilash. We do not touch the target variable, right? We do not make any changes in the target variable, and I have clearly mentioned in the last project discussion session, right? Still I'm getting answer like yes, right? We do not make any changes because by using any data point, by beside due to any reason, we do not transform the value of our target variable. Okay, even we do not drop the null values. If the if we do not replace the null values, if the null values are there, we directly drop them, right? Because if you are changing, if you are changing the original value, right, then how will you able to identify whether you are able to solve the task or not? Because the values are transformed, right? So if the values are transformed, then definitely it will data. The second thing, this is a regression problem. Why? Because here the values are the continuous. Continuous means the difference between the number of unique values and the size is very less, right? So this is a regression problem. In the regression problem, if you are changing the values, the target variable, right, by using the z-score method, so the target variable is independent. Just because it is independent, then in the target variable any values can be present. So if you are considering that point as a date as an outlier, then definitely you will lose around or you can say almost all the data, right? So we do not make any changes in the outliers. So in the target variable, we do not detect the outliers from the target variable. Clear? Yeah, target variables are dependent, right? Target variable are dependent, means target variables are dependent data, but the values present in the target variable are independent. Independent means they are not related with the values in the same column. They are based on the independent variables. Means we are, how we are predicting the target variable is basically what we are doing. We are making a combination of the input values, right? Based on the input values, we are finding out whether a particular target variable is possible or not, right? And just because they are dependent on the target variable, on the independent variables, so that's why we are not making any changes. Okay, now what we are doing here, we are storing the open, high, low and the volume column in a new feature that is known as the out features, and then after that we are using z-score on the out features. The z-score method is basically detecting the, is calculating the z-score value, and then after that we are using np.abs, means numpy.abs method, and this abs method is basically used to for the absolute value. Absolute value means it will cancel the negative values. Okay, so np.abs is basically used for the absolute value, and when we are checking the z, then we are getting the data in the data frame, but you can also get the output in the array format. Okay, you can also get the data in the array format. So here you can see after transforming the value, after using the z-score method, all the values are basically in a particular range, that is 1.40, 1.36, 3.2, 3.1, 3.31, 3.8. So basically these are the z-score values, right, for each data point. After that, what we are doing, we are checking the threshold value, and the threshold value is 3. Like I have clearly mentioned about what is the reason behind the 3. Now here we are using np.where z is greater than 3, and when we are using, here you can see we are getting the output in the array format. Here these values are basically representing the row number, and these values are basically representing the column number, right? So here in the 720 row and the third column, the outliers are present. And how we can identify? If the z-score value is greater than 3, then after the 721 row, third column, 722 row, third column, 723, third column, and for example here the second last value 2415 row and the second column, these they are on at these data points, okay, the outliers are present, and for that we are using z.iloc row number and the column number. If you check for the 720th row and the third column, the value is 6.3349. That is basically much larger than the threshold value, and our threshold value was only 3, right? So that's why here the outliers are present, right? Now what we are doing here, we are going to remove the data points, right? And to remove the data points, what we are doing here, we are writing df. Why we are writing df? Because this df means we are dropping the values from the whole data frame. Okay, means whatever the outliers we have detected from the independent variables, for those locations, means the locations where we detected the outliers, we will remove that particular row from the whole data frame. Okay, from whole data frame I'm saying. Clear? Means we are detecting the outliers from the independent variables, but the locations we are dropping from whole tar for whole data frame. That's why here I am writing df. Then after that I am using here z is less than 3. Means what we are doing, we are keeping all the data points where the z score value is less than 3. That's why here we are writing dot all and x is equal to 1. Means we are performing the operation column wise, right? So what we are doing, we are keeping the values which is less than 3, right? And when we are checking the shape after removing the outlier, the shape of the data is 2360 and 5 rows. It means how many data points are removed? Around 55 or 56 data points are basically detected as the outliers, and they are removed from the whole data frame, right? What is the second thing? What you can do, first of all, you can split the data into x and y, means independent variables, and the y variables, right? Then after that, because here you can see these data points, these 4 data points are basically a part of our independent variable, right? Now what you can do, you can apply the z-score method on the independent variable so that you can detect the outliers from the independent variables. And then after that, first of all, you can drop those data points from the independent variable, and then after that you need to drop the same data points from the target variable. Clear? Or directly you can use this way. Clear? So this is all about the z-score method that we are using to detect and remove the outliers. The second method is basically, okay, here you can see the old data frame size was 2416. New data frame after removing the outliers is 2360, and the total loss percentage, data loss percentage, is 2.31. Please remember that whenever we are working on the dropping of the data, right, we do not, after removing the outliers, we should not lose the data more than 10%. Please remember that after removing the outliers we are losing the data more than 10%, then you should select the another method to drop the data. Okay, sorry, to detect the outliers and to drop the outliers. Second thing is, whenever you are applying the data points, I hope you have checked that what we are doing, first we are detecting the outliers, right? We have used the box plot. After removing the outliers, if you are again using the box plot, again you will see the outliers. Why? Because if the data points are changed, then again the first quartile, second quartile, third quartile, fourth quartile will be changed, right? Based on that, again you will get some outlier data points in the box plot. It does not mean that you are going to apply the same data point, same z-score method or any particular method continuously to remove the data points, right? You need to drop the outliers only once from the data point, from the data frame. Clear? Okay. Now here, this is the data df1. Basically whatever changes we have made, we have stored in the df1. Means we have not made the changes in the original data frame, right? Now we are going to discuss about another method, that is IQR, how to remove it. So what we are doing here, we are basically checking the first quartile, that is 0.25 on the outlier out feature. Out feature means this is the variable where we have stored the 4 variables, right? First quartile, then after that we are selecting the second quartile, then we are calculating the IQR. IQR is basically the difference between the third quartile value and the first quartile value, right? Now what we are doing here, we are creating one more condition. If the first quartile, right, from the first quartile, if we are subtracting the 1.5 times of IQR, then it is deciding the minimum value. Okay, this is basically used to calculate the minimum value. Means from the first quartile, if we are subtracting the 1.5 times of the IQR, then it will decide the minimum value. And if we are adding 1.5 times of IQR, means IQR on the third quartile, then it will decide the maximum value. And if any data point, okay, if any data point that is less than the lowest value and or greater than the maximum value, it will be considered as an outliers. But what we are doing here, we are checking all the data points which are either less than which are not less than the lowest value, or which is not greater than the maximum value. We are keeping it and we are removing the other data points. Clear? Okay. Now, after removing the outliers, whatever the changes we are making, after making the changes, we are storing in a new variable, that is df2, right? After that, if you are checking the shape is basically 2306. It means around 110 rows has been removed as an outlier, right? And also you can use the IQR method to transform the values instead of dropping them, right? Then after that, what we are doing here, we are checking the data loss percentage. After that, after IQR method, the data loss percentage is basically 4.552%, and earlier it was around 2 point something percent, right? So now we are moving ahead with the first one, that is JD-score method, because it is giving less data loss and it is also removing the outliers. So why we should go for the more data loss? So what we are doing, whatever the values are present in the df1, we are storing the df variable, right? now 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 we are going to check the distribution of the data, and for that we are using the dist plot, right? When we are checking the dist plot, here you can see how the data is basically behaving in the open column, high column, low column, close column, and the volume column, right? So here, if you check here in the low, in the open, in the high, in the low, in the close, and the volume, then you will find out that all the data points are almost normally distributed here, normally distributed. But if you check for the volume column, then the data is basically left skipped, right? Now here we have mentioned that from the above distribution plot, we can notice that the data almost looks normal in all the columns except the volume. And to confirm this, what we are going to use, we are going to use the skip method, right? And for that, here we are using df.skip, right? In the df.skip, when we are checking for the open column, the value is 0.16. For high it is 0.16, for low it is 0.16, for close it is negative, means negative 0.1, 0.1, negative 0.1. But for the volume it is 1.17. Okay, basically here it is showing that this is a skipness. Again, based on the domain knowledge, we are checking whether the skipness is present or not. But default skipness value is negative 0.5 to positive 0.5. So if we check for for these four columns, so the skipness value is in the range, but for the volume it is not in the range. So we will try to reduce the skipness by applying the transformation method, right? Because volume is not our target variable, right? So here we are using the np.cuberoot method on the volume column, and we are storing the same value variable, right? We are storing the values in the df volume column. After that, if you are checking, after applying the transformation method, if you are checking the volume, it is basically negative 0.049. that is much closer to 0, and 0 means there is no skipness, right? So if you check the data, if you check the dist plot here, so here you will find out that the data is basically almost normal. Okay, it is a binomial data, but it is basically almost normally distributed. So it means the skipness has been removed from the volume column. Clear? Okay. Now, then after that, the skipness, if you are checking again, you will see that here the skipness is basically removed, right? So basically the skipness has been removed. Now we are moving ahead to check the correlation value, right? And to check the correlation, because the correlation, whenever we are checking the correlation, it is basically finding out the relationship between the independent features as well as one independent feature with target variable, right? So here, if you're checking the correlation function, then here you can see the correlation value between the open and open is 1.0. Between the open and high, it is 0.99. For open and high, it is 0.99. For open and close, it is 0.99, and for the open and volume, it is 0.69. That's why we are mentioning that there is a high positive correlation between the open and high, open and low, open and close, but there is a positive relationship, right? Not a strong positive, right? In the same way, for the high 0.9 and 1 0.9, it means I can say that there is a perfect all the variables of the data frame except my a volume variable, all the columns are perfect positive correlated with each other. Perfect positive means the correlation value between these features is 1. That is the maximum value, right? If you are making any changes in one variable, then it is reflecting in the another variable. Clear? In the same way. Clear? Now if you want to confirm the heat map, then you can apply, but here you can see just because all the values are 0.9999, now it is rounded off to 11111, and here you can see it means, okay, if all the variables are highly positive correlated with each other, it means there is a multicollinearity issue is present. Why? Because if two or more than two independent variables are highly correlated, highly positive or negative correlated with each other, it means there is a issue of multicollinearity. Clear? And to drop the multicollinearity, to handle the multicollinearity, we are going to use the VIF method, right? But before VIF method, what we are going to do, first we will drop the values here. And to drop the values, what we are doing here, we are dropping the close variable, right? Then after that, we are selecting the close variable here. Clear? X, in the X, all the independent variables are there. In the Y, the target variable is there. After that, we are using the scaling method so that we can reduce the biasness between the features, right? And for that, we are using the standard scaler. Why? Because the standard scaler used to scale the values by considering the 0 as the mean and unit value as 1. Okay, so here you can see all the values are basically, first we have initialized the standard scaler, then after that we have applied the standard scaler on the X value, and just because of the fit transform method, my value points are basically, first my data points are basically, by using the fit method we find out the patterns and the insights from the data, and then after that, based on the learning, my data has been transformed by using the transform method. And just because the scalar method used to give the values in an array format, that's why here we are creating the data frame. And to give the column names, we are using x dot column, means there is a one variable name as column in the data frame, and for in that we are passing the x dot column. It means we are checking the, we are using the column names that is basically present in the x variable, that is basically independent variable, right? After that, here the values are same, 2360 and 4 rows. Now we are moving ahead to check the variance inflation factor. So here, if you are checking the variance inflation factor, first we are importing the library from stats model dot stats dot outlier influence. Import variance inflation factor. We are creating a data frame, and first of all we are using a for loop that will iterate over the length, means that will iterate over the columns of x variable, means your independent variable. Then after that, we are applying the variance inflation factor on the values of the independent variables and the correct iteration, right? You are saying we converted date column only for graph purpose. First of all, we have not converted the date column only for the graph purpose, but your date column is basically giving information. Just wait a minute. So someone is asking, we converted the date column only for the graph purpose. So basically we have not converted only for the graph purpose. So basically whatever the analysis you are doing, right? Over the period of the time, if you want to find out the relation, if you want to find out the information based on the data, then in that case it will be based on the column, right? Based on the date column. So basically the data should always be in the correct format. If it is not in the correct format, then whatever the operations you are performing, whatever the observations or your analysis is mentioned is not correct, right? I have clearly mentioned that if you are taking the data, if in the last, like in the last lecture, if the data was present in the double quotes, and if you are trying to perform any kind of operation, then that has no use because the output will be different, right? So in the same way, the data should always be in the correct format so that you can perform the correct analysis and you can make the correct decisions, right? Not so here it is not only for the graph purpose, it was for the analysis. So analysis can be done by using the graphs, without the graphs, right? It is not mandatory to do the to plot the graph, right? We can also use many kind of graph where the my date column was not using, like we have used the rect plot, we have used the scatter plot, right? But just because we want to perform the operations, we want to do the analysis based on the time graph analysis by using the line plot over the period of the time, at that time it was mandatory, right? Okay, so here we are using the variance inflation factor, and then after that here you can see for the open value it is 1781, high it is 2209, for the low it is 1999, and for the volume. But based on our previous discussion, the column that has the highest VIF value must be dropped. Here the high column has the highest VIF value and it should be dropped, but we are not going to drop. Why? Because see, if we are going to drop, it means around 20% of my data would be removed, right? And 20% of the data has a very huge impact on the performance of the data, especially when all the data are gathered. We have checked the analysis and we have found out that all the values are related because this is a stock based data, and if one is changing, then another one is also getting affected, right? So in that case, by considering all the analysis, previous analysis that we have performed, we are not going to drop the data. Clear? If the same data was present, then that was a different case, but just because here the different data is present, these data are basically highly correlated because in the real life they are getting affected, right? And even as per our analysis, when we use the line plot, when we check the scatter plot, when we check the pair plot, every time it was showing the strong positive relationship, right? So we are not going to drop the multi-collinearity issue, because if we are dropping here, then definitely we will drop the whole data, right? So instead of that, we can handle this case by using the regularization method like lasso and ridge. Okay, they will handle such cases in the regression case. Clear? Okay, now we are going to build the model, and for that what we are doing, we are first importing the data which will used, sorry, we are importing the library, the method which will be used to split the data into the train and the test data. Then after that, here we are importing two important libraries, that is mean absolute error and mean squared error, that are basically the error metrics in the regression part. Then after that, we are importing the R squared value, that is basically, again, that is one of the important parameter which is used to find out the performance of the regression model, because error metrics are basically used to find out the difference between the predicted value and the actual value. But the R squared value is basically defining how well the model is fitted on the data, how well your model is able to explain the data, right? Now here, then after that, we are importing two important libraries. First one is gradient boosting regressor, and second one is linear regression, right? Now here we are creating our two variables, right? Max accuracy and the maximum random state with the initialized value 0. And then after that, I'm taking a range of, I'm using a for loop that will iterate over the range of 1 to 200, right? And then after that, I'm using the train test split so that I can divide the data into x train, x test, y train, y test. And we are splitting the data by using the x variable, that is our independent features, and y as our target variable. And here the test size is 30%, that is basically our, means 30% of the data will be used to for the testing of the data, and 70% of the data will be used to train the model, so that our model can learn from the training data. And the random state is equal to y. That is basically random state is a random generator which will be used to pick the data randomly for the x train, x test, y train, and y test. Then after that, what we are doing here, we are initializing the model, linear regression model, and storing in a LR variable. Then after that, LR dot fit, here I'm writing x train and y train. It means I'm fitting my model on the training data, so that my model can learn from the training data. It can find out different kind of information, right? And based on that, it should be able to identify the target variable. Sorry, it should be able to identify the target variable based on the input variables, means independent variables. Then after that, we are making the prediction on the x test. X test is basically a part of the independent variable, and just because it's an unseen data, means your variable, your model has never seen this data. It has no information. So this is a new data on which your model will predict the target variable, right? Then after that, we are going to use the R squared, that will basically will be calculated by comparing the y test, that is the actual target variable for each data points on which your model has made the prediction, and your target and the predictions made by your model. Then after that, what we are doing, we are storing in a new variable, that is ACC, right? And then after that, we are using if condition. If the current ACC value is greater than the previous maximum accuracy value, then we will update the accuracy, sorry, we will update the maximum accuracy value with the value which is present in the accuracy parameter. So if it is 60 and it is 0, then definitely 60 is greater than 0. Now the maximum accuracy variable will be updated with 60 value, right? At the same time, maximum random state will also be updated, right? In the same way, it will check around 200 times. After that, after checking, we are finding out that the maximum R squared value is 0.9997, right? That is basically 1, which is very rare in real life, right? On random state of 139, right? Again, by using the same random state, we are going to split the data again into the train data and the test data by x train, y test, y train, y, sorry, x train, x test, y train, y test. Train test split, same data, but here the random state is maximum RS instead of I. Why maximum RS? Because in the maximum RS variable, we have stored the best random state where your model is giving the highest performance. So here you can see in the maximum RS 139 is stored. So either you can directly write 139 or you can directly give the maximum RS. But why I'm using maximum RS? Because if I'm running the code again after several times, or if I'm making any changes in my steps, then definitely my maximum random state will be different. Clear? Now, then after that, what we are doing here, we are importing some other libraries like linear regression, random forest, decision tree, k-neighbors regressor, lasso, and the ridge, right? Now here, what we are doing here, we are initializing the model, linear regression model, and we are fitting the model on the train data. We are making the prediction on x trace data. And then after that, we are doing one more thing. We are also making the prediction on the train data. The train data means the part of the target, or the part of the independent variable on which our data has been trained. Means my model, my model was trained, and my model has all the information about the x train data as well as the y train data, because my model was trained on the same data. Clear? Now what we are doing here, we are basically using the R squared value, right? So here R2 score, y test, pred, LR, right? We are making the prediction for the test data. Then after that, we are making the prediction for the training data, and for the training data, we are passing the y train, again the data on which my target variable was trained. Sorry, my model was trained, and the predictions that is basically made by model on the training data on this data, right? Then after that, we are checking the mean absolute error, mean squared error on the test data, not on the training data. Then after that, we are also taking the root mean square error of the data, and for that, what we are doing, we are taking the square root of the mean squared error. Clear? Now Here, if you check, the R squared value on the test data is 99.97, but on the training data is in 99.96. Okay, that's fine. That is a very less difference. Mean absolute error, it is 1.2, and mean square error is 3.2, and the mean square error is 1.8. So basically, in the regression model, we check the error matrix as well as the R squared value, right? So basically, whenever we are checking such things, we always try to get the high R squared value and as low as possible the error matrix, right? The low error matrix means there is a very less difference between the predicted value and the actual value. Clear? Okay. Then after that, to confirm the same thing, we can use the scatter plot, and we are using the scatter plot between the predictions and the actual value, right? And here, if you check, so the prediction value and the actual values are exactly same. If you check the best fit line, whole data points are basically present in a same in the best fit line. It means there is a very less difference here. Clear? Now we are building another model, that is basically random forest model, and for the random forest model the R2 score is 99.93. For here it is 99.99. Okay, that is basically greater than that test data. Mean absolute error is basically 1.83. It is higher than the previous model. Mean square error is also high, that is 9.48, because in the previous model it was only 3.24, right? So it means the error rate for random forest model is high as compared to linear regression model. Again, we are checking the KNN model. In the KNN model, the accuracy, sorry, the R squared value is 99.80, whereas the performance on the training data is 99.86. If you check here the values, the mean is absolute error and the mean square error, if you check here, then the mean square error is to 26.477%, means that is much higher as compared to the last two models, right? Here the mean absolute error is also high. In the same way, we are checking for the gradient boosting. In the gradient boosting, accuracy is fine because everyone is getting 99.9797, something like that, right? But if you're checking for the mean absolute error, so here you can see the mean absolute error is less than this model, right? This model means KNN model, but it is higher than the random forest and the linear regression model, right? In the same way, we are using the regularization method. First one is lasso. In the lasso, you can see we are getting the accuracy as closer to linear regression model. But if you check the mean square error, then mean square error is basically greater than all the previous model except the KNN model. Also, the mean absolute error is also high. The root mean square error is also high here. Clear? Okay. Then after that, we are moving ahead and we are again training the model ridge, and ridge is another regularization method. R squared on the training data is good. R squared value on the tested data is also good. But if you check the root mean square error, then mean square error and the mean absolute error, then basically the mean square error is less than this one. Okay, and other remaining model, but it is higher than the random forest and the linear regression. Clear? Yeah, lasso ridge is used in the linear regression model because they are the regularization methods. Okay, so basically the the lasso and the ridge is used for the linear regression method. These are the regularization methods for linear regression, but you cannot use it for other algorithms. Clear? Okay, so basically again we are building one more model that is basically based on the decision tree. How do we know which kind of test and train method will be used in every project? So basically, I hope you know how to identify whether it's a classification algorithm or it's a regression algorithm. If it's a classification algorithm, then you can use the classification. Sorry, if it's a classification problem statement, then you can only use the classification algorithm to complete that project. If it's a regression problem, then you can use only the regression algorithms. Now the algorithm name is same like decision tree, right? Random forest, then after that your support vector, knn. But whenever the name, after the name regressor is mentioned, it means that particular algorithm is a regression algorithm. If the classifier is mentioned, then it indicates that this is a classification algorithm, right? If you are working on unsupervised machine learning, then in that case you can use other algorithm like k-means, right? dbscan. Then there are different kind of problem statement, right? So first of all, you need to identify whether if you are working on supervised machine learning algorithm, sorry, machine learning project, then in the supervised machine learning there are only two possibilities: either it is supervised or it's a regression, right? So it is a, if whether it's a classification or it's a regression. For the classification, you have to check the target variable, right? I have clearly mentioned in the last uh, session how to identify, right? If it's a regression, then you need to use the regression algorithms. Clear? For sentimental analysis, there are different algorithms. First of all, again, you have to check which kind of data you are using, right? For the sentimental analysis, again, the different kind of the algorithms are there. In text data only, can you please let me know which kind of text data only you are asking about? Please let me know as soon as possible because we have very less time left. So you are saying sentimentalness comes under deep learning. I think going ongoing course. So basically, we have not covered the sentimental analysis, and we are not aware about it. But if you really want to work on the sentimental analysis, then you can use the RNN. In the RNN, there are different kind of RNN, fast RNN, faster RNN, right? Then after that, you can use the CNN as well. You can use the LSTM method, like that is basically long short-term memory algorithm. You can also use the Navy bias because the Navy bias is basically used to find out the it is based on the uh, one multiplicative algorithm, right? That is basically it is treating all the data as independent data, right? So there are different algorithms are there which can be used for the sentimental analysis. You are extracting tweets, for that which algorithm you can use. So basically I have mentioned that, right? You can use the support vector because the support vector is basically worked on the based on the density, kernel density, right? So based on the kernel you can use the SVM, right? Because it will create different hyperplane. You can use Navy bias, you can use LSTM, you can use fast RNN, you can use CNN, you can use random forest, you can use many algorithms are there, right? Okay. So, okay, that's fine. Now here you can see the algorithms are there. Sorry, here the performance of the uh, algorithm. Then after that, we are building the model for the decision tree, and in the decision tree, here you can see the R squared is basically 99.87. Again, the training data, it is giving 100% R squared value. But if you check the mean square error and the mean absolute error, it is quite high, right? Then in the same way, SVR, in the SVR, we are giving the 95% of the R squared value. For the training data, it is 97. But if you check the mean squared error, it is 665, right? It is too much high as compared to the values that are present in your data, as well as the performance given by your previous models, right? Then after that, if you check for the extra tree regressor, again you can see all the values are giving, basically all the models are giving the R squared value in the range of 90. Basically most of them is giving in the range of 99 to 100. Then after that, the squared value is basically in the range of 1 to 12, right? In the same way, right? Now we have checked about the cross validation, we have checked about the mean squared error, we have checked about the mean absolute error, right? So basically R squared is basically defining how well your data, how well your model is basically fit on the data. But your error matrix is used to give the information about how the data is performing on the unseen data. Okay, so basically we have checked the R squared value, we have checked the error matrix, right? Now it's time to check the performance of the model. Means we need to validate the performance of the model, and to validate it, what we need to do, we need to check the cross validation score. Like we have mentioned about the cross value score, about the LUCV, right? I hope you have heard about the k-fold cross validation method. So here we are going to use the cross value score, and for the cross value score, in the default scoring parameter for the regression model is R squared value, right? So what we are doing here, we are checking the cross value score. Here we are first we are giving the name of the model, then after that we are giving the values, that is basically independent variable and the dependent variable, then what is the fold value, and then after that what is the scoring parameter. Clear? So here our scoring parameter is R2, because this is a regression algorithm, and in the regression algorithm, if we are using the accuracy, then definitely we will get an error, right? So the parameters that are used to check the performance of the model, of the regression model, is R squared value, adjusted R squared, mean squared error, mean absolute error, root mean square error, right? So here what we are doing, we are validating the R squared value. You can also validate the mean absolute error, mean squared error, or any other parameter. So here when we are validating, here you can see after the validation I am getting the R squared value 99.64 for the linear regression model, and the difference is basically 0.33 only. That is basically, that's fine. In the same way for the RFR, if I'm selecting, so here for during the first iteration I am getting the R squared value only 0.58, then 0.97, 98, 99, and 91, right? And the average of the all the R squared values 89. But the R squared value which we were getting during the tested data, it was around 99. So here you can see there is a huge difference. The difference is basically 10, right? So if you are getting the R squared value closer to 99 or 100%, and after that the cross validation you are getting 89%, then it means that there is a huge difference. Means whatever the performance given by your model, right, that was not correct, that was not absolutely correct, because here you can see there is a huge difference. Then after that, for the cross validation score, I'm using the KNN. In the KNN, I'm getting the R squared value only 56%. Again, it was giving the 99% of the accuracy. During the cross validation, when we are trying to validate the performance of our model on the unseen data, then we are getting the difference of 43%. Just imagine 43% of the difference. So this is a clear indication that this model is overfitting. Just because of the overfitting, my model was giving the highest R squared value, and if we were selecting the R squared value without validating the performance, in that case it was wrong, because my model was influenced because of the performance of my model was influenced because of the overfitting. right? There is a huge difference. The 43% is too much, right? Now, in the same way, if you are checking for the GBR, that is basically gradient boosting regressor, the difference is basically 85%, again 30%. Again, this is a huge number. If you are working on a real case data, for example, in the medical line data or in the security line data, right? And if this is the percentage of the different, if this is the difference percentage, right? Then definitely that is a concern point, right? We cannot ignore this much difference, right? Then after that, if you check for the cross validation of lasso, it is giving 19.4% and 5% of the difference is there, right? So that is fine, right? Then after that, for the rich, we are selecting and it is given 99.47 and the difference is only 0.47. So basically the linear regression and that is giving very close accuracy, right? Accuracy difference means whatever the predictions are made by my models are almost accurate. For the DTR, it is 89%. Again, the difference is basically 10. The difference is 10, right? Then after that, we are checking for the SVR, that is support vector machine, and here you can see the R squared value is basically negative. Okay, it is a negative, and just because it is negative, it means the whatever, even if you check the SVR, the SVR decision tree fridge, okay, SVR, if you check the in the SVR, the mean squared error was quite high, it was 665, right? Earlier it was given 95%, now it is giving only -5%. It means you can see what is the difference here. The difference is quite high, right? It is giving because of some mistake, right? But here the difference is too much, right? And in that case we cannot select this model. Then after that, ETR, that is basically extra tree regressor. In the extra tree regressor, it is 90.6% and the difference is 90.32. Now you can see, before building the model or before checking the performance of the model, we cannot select any model directly. Why? Because see, every model has different functionality, every model has different parameters. These parameters are working in a different way. They are of their the mathematical calculation is different for each model, right? That's why here you can see the performance of every model is different. Earlier they were giving, everyone was giving 99.99.99 point something like that, right? Okay, so earlier the R squared value was basically very closer, right? And then after that, the error matrix was 6 to 5, something like that. In some cases it was 12, it was 50. But now here you can see the difference is quite high. When we are validating, we are getting the real performance of the model, right? So we cannot decide, first of all we cannot decide any model directly, any algorithm directly. Second thing is, whenever you are checking the performance, make sure to validate the performance of the model, and based on that you can select any model, right? So here, from the difference of R squared and the cross validation computed on R squared method, we can conclude that ridge and the linear regression as our best fitting and best performing model. There are two models. Why? Because the difference between the R squared and the R squared computed on, sorry, cross validation computed on R squared is, in one model it is, I think, 0.33, okay, and in the second one it is 0.47, right? So basically there is no huge difference between these two, and just because ridge is our regularization method, so we are selecting this one, right? Now then after that, we are moving ahead for the hyperparameter tuning, so that we can get the more generalized performance of the model, and if possible we can increase the performance of the model. That is basically again 99%, so we cannot increase it. But it is not mandatory that whenever we are using the grid search CV or randomized search CV or any algorithm, the performance will increase. It may decrease also, right? It may decrease. Why? Because every parameter has every algorithm has different parameter. For different parameters there are different list of values, right? and every list of values has a different impact on the data, and it totally based on the type of the data, what data is present. So whenever you are building the model, the performance of the model may decrease. If it is decreasing, it is by 0.1, 0.2 or 1%, then that's fine, right? But if you are getting 50% of the R squared value and it is decreased by 1%, then that definitely it's a point of concern, right? But if you're getting 99, 95% of the accuracy, then that's fine. But again, I'm not saying it is fine, but if it is removing, if it is reducing, again change the parameters and see whether the performance can increase or not. Because in real lifetime, we always try to achieve the accuracy or the performance of the model closer to 100, and whatever the performance we are getting, it must be correct, it must be accurate. Okay, now what we are doing here, we are importing from sklearn dot model selection, import grades as cv first parameter, that is alpha. There are different values we have taken. Fit intercept, two values are there. In the solver, there are different solvers are present here. Positive, there are two possible values, that is false and true. Random state, we have taken this one, you can change values, right? Then after that, we are fitting the ridge model in the grids as cv algorithm. Params in the there, these are the parameter I have taken. Cross validation value is 5. Then after that, we are fitting the model on the training data, and we are checking the best parameter. For the alpha, it is 0.05. For fit intercept, it is true. For positive, it is false. For random state, it is 1. For solver, it is LSQR, right? After that, what we are doing, we are after initializing, we are storing in a new variable that is named as model. We are fitting the model on the training data. Then after that, we are making the prediction on the test data, right? Then after that, we are checking the R squared value, and it is 99.97% of the R squared value, right? Earlier it was, I don't know what was the percentage, R squared, R squared, R squared, R squared. Performance was 99.95%, but now it has increased to 99.97, right? 99.97. So you can see the accuracy has been increased. Mean absolute error, it is 3.31. Earlier it was just wait. Okay, earlier it was 6.47. So basically our error rate has basically decreased, right? So the error rate must be as low as possible. So you can see by looking on the error rate as well as the R squared value. So here you can see the performance of my ridge model has been increased, because here the R squared value is decreased, mean absolute error is decreased, my root mean square error value is decreased, but my R squared value is increased. So we always try to increase the R squared value, and we always try to reduce the mean absolute error and the mean squared error, because the error rate must be as low as possible, right? Now we are now we are saving the file, and for that we are using the pickle. In the pickle, first of all, we are writing the file name tesla stock.pkl. This is the name of the file. Then we are using the dub method so that we can serialize the model, and here writing model. Then open is a method that is used to read the file, and here I'm writing wb. It means I'm write binary, means I'm serializing the model. That's why in the binary format, that's why here w is mentioned. Once the model is saved, if you want to load in future, you can use loaded model.pickle. Pickle.load is a method that is basically used to load the model, means to deserialize the model, and that's why here we have mentioned the rb. It means read binary, right? Again, we are using the open model. Once it is loaded, we can store in a new variable, that is load model. Once it is loaded, if you want to check the performance of the model, you can directly use this library to use the any parameter, score, R squared, or your any another parameter to check the performance. Here it is giving 99.97%. Okay, one more thing, score. Whenever you are using the score parameter, doesn't matter in classification or in regression part. If you are using in classification, it will calculate the accuracy. If you are checking in the regression part, it will check the R squared value. Clear? Okay. Now, if you want to check the predictions, then you can create a data frame. Here in the data frame, first of all, I'm taking a list of values. That is basically here I'm making the prediction on the expected data by taking all the data points, and then after that I'm taking the y test. Here I'm considering all the data points. Then I'm creating index value, that is predicted and the original value, and here you can see this is the predicted value by my model, this is the original value, right? You can compare in this way. Now I hope now you are well aware about how the regression algorithm works, how to work on the machine learning, supervised machine learning problem statement, means classification as well as the regression. But before moving ahead, there is one more case. Like we have discussed two cases, and more in both the cases there was a single file, right? In this single file, basically your target variable as well as your input variable, means independent variable, were present, right? But in if the data is given into two different files means one file is for training purpose and one is for testing purpose, then what does it mean? Okay, what does it mean? It means, see, I hope you have checked that you have divided the data into four parts: X train, X test, Y train, Y test. So the training file is basically a combination of X train and Y train. Why? Because in the training file, your independent variable as well as the target variable is present. But your test file is only about the X test, because here the independent variables are present. Now the question is how we should work on such kind of projects. So what we need to do, basically overall the process is divided into two parts. First one is step 1 and second one is step 2. No, do not concat the file. Okay, I'm going to tell you why. See, first of all, there are two possible steps. First one is step 1 and step 2. In the step 1, perform EDA, pre-processing, feature engineering, feature selection method, everything. Means you need to do all the analysis part by using graphical or non-graphical analysis, right? In the step 2, you need to split the data into feature and the target variable. Then after that, again divide the feature and target into four parts: train data and test data by using train test split method, or you can also write your code. Then after that, build the model that we have done. We have checked the performance of the model. We have used the cross validation to validate the performance of the model. We find out the best performing model. We perform the hyperparameter tuning to get the generalized model of the model. Then after that, we save the model, right? These are the two steps basically we are doing in any kind of the supervised machine learning project. Now, first we are talking about the train dataset file, right? There are two files. Someone is saying we can concatenate it, but just because I have clearly mentioned that in the training file, the target variable as well as the independent variable is present. But in the test file, only the X test is present, means the target variable is not there. So if you are concatenating both the files, then you will see the number of null values in the target variable. Again, in the target variable, you cannot fill out the null values, you cannot replace them, right? So again, if you're not replacing, then that is the case. If you're replacing, then again you have to split it. So what do you need to do? Instead of concatenating or merging the files, what do you need to do? You should first apply the step 1 and step 2. These step 1 and step 2 on the train dataset file. It means you need to do all the feature engineering, pre-processing, EDA, feature selection, whatever you want to apply on the training file. Then after that, divide the training file into two parts: features and the target variable, like we have completed in these two projects. Then after that, same variables should be divided into four parts: training data, test data, means X train, X test, Y train, Y test. Build the model, train the models, check the performance of the model. After checking the performance of the model, do the analysis, do the hyperparameter tuning. Sorry, select the best performing model, do the hyperparameter tuning, save the best model, right? Then after that, what you need to do after saving the model, leave it. Now go to test file. On the test file, you need to do all the same activities of step 1, means whatever the steps you have performed on the training data by using the step 1, means EDA, pre-processing, feature engineering, etc. Even you need to use the same methods, whatever the methods you have applied on the train data, in the same manner. You need to use the same method, same everything in the same manner on the test dataset file. After completing the step 1, you do not need to go for the step 2. What you need to do after completing the step 1, you need to load the saved model. Which saved model? The model that you have saved in the train dataset file, right, during the step 2, and use the whole test dataset file. Test dataset file I'm saying, okay, this file, the second file, and you need to pass in this variable. Which variable? In where is the predict, right, in this one. Means you need to give the model name dot predict. Instead of the x test, you need to give the whole test dataset file and you need to make the prediction. That's it. How in this way we are working on the file when the dataset is divided into two equal parts. Clear? Am I clear? Please let me know because we are already running out of the time. Okay, great. Okay, I'm sharing the CSV file. Okay, this is the GitHub link. Okay, you can visit there, and I hope you know how to download this file, right? If you don't know, yeah, I need to again, I'm telling you, if you click here, right, it will download the file. It will be downloaded, right? And then after that, either you can download the file and you can pass the link of the file, or you can use the raw link of the file and you can save here. One more thing, if you are passing the file, okay, just wait. Okay, whenever you are passing the file here, right, please pass the whole path of the file in this method, and then after that replace the backslashes with this front slash. If the backslashes, because if you are using Windows operating system, then definitely you will be using the backslashes in the path of the file. Remove the backslashes, sorry, replace the backslashes with the front slash and then execute the code, and please pass the whole path of the file. Clear? Now again, I'm saying I have discussed two projects in two different project discussion session. You can go through that. Okay, you can go through the recorded video of the sessions because we are going to share the recorded video of this session with your institute, right? You have the time till uh, coming Thursday, right? On coming Thursday we will start the project practice phase where will we give the projects so that you can practice, and after the deadline, right, from the deadline within 8 working days, 8 working days I'm saying, okay, within 8 working days your SME will provide the feedback and the marks for your submitted practice projects, but not the solution, because there is no single solution for any problem statement. Second thing is, should we remove the target variable from the test file while doing step 2? No, basically we are not removing, right? We are just splitting the data, whatever the operations we have performed here, right? So you can do that. Okay, so please remember that do not copy the exact code in the exact manner that I have mentioned discussed here, otherwise I will give you directly 0 marks. Use your logic, make your decisions based on the analysis, try to use more plots, right, and just try to complete the project. Now you have Sunday, Monday, Tuesday, Wednesday, Thursday. I know that Tuesday and Wednesday is your week off, but you can utilize your time to revise everything. Now you have 4 days: Sunday, Monday, Tuesday, Wednesday, to revise whatever we have discussed today. And then after that, practice in your Jupyter notebook. And then after that, we will start the project phase for your batch. Okay. So that's it for the today. Thank you everyone for joining the session. We will share the recorded video of this session with your institute, and they will upload in the forum that they are using, and you can go through that. Clear? Okay. Yeah, we will provide the maximum time, okay, to complete the project. Don't worry, I'm not going to give you 1 day or 2 day to complete a project. Okay, I will give you the sufficient time to complete the projects. Okay. Okay. Thank you so much and have a great day ahead.